So let us discuss another problem on steam nozzles. Okay. So the problem is given as a dry saturated steam enters at the nozzle at 15 bar and it is discharged at a pressure of 2 bar. If dryness fraction is 0.96, what will the final velocity of the steam? Neglect the initial velocity of the steam. Okay. See, here in the problem it has given that at the entrance of the steam nozzle it is in dry state. Therefore, we can directly take the value of Hg as enthalpy value at 15 bar from saturated pressure tables. Okay. So now in the problem it has also given that if 10% heat drop lost due to the friction, find the percentage of reduction in the velocity. Okay. So now given conditions are initial pressure is 15 bar, final pressure is 2 bar, dryness fraction is 0.96, that is x. Now from the steam tables, if you take the enthalpy values, then at pressure of 15 bar, H1 is equal to Hg, that is 2789.9 kilojoule per kg. At pressure of 2 bar, we can take the value of Hf as 504.7 kilojoule per kg, Hfg as 2207.6 kilojoule per kg. And since the outlet condition is in wet condition, to determine the enthalpy at wet condition, the formula is H2 is equal to Hf2 plus X into Hfg2. So we know the value of Hf2, we know the value of Hfg2, which are collected from the steam table book at saturated pressure tables at 2 bar, and the dryness fraction is given in the problem as 0.96. Okay. So now if we substitute that in the equation, we used to get it as 504.7 plus 0.96 into 2201.6. We used to get enthalpy at point 2 as 2618.2 kilojoule per kg. Okay. Now the exit velocity of the nozzle. The exit velocity of the nozzle can be taken as 44.7 into square root of H1 minus H2. Therefore, we know the value of H1 and we know the value of H2, and if we substitute that, we used to get the velocity of the steam, exit velocity of the steam as 585.5 meter per second. Okay. Now, if there is a enthalpy drop due to the friction, it has given that there is a 10% heat drop due to the friction. So therefore, the enthalpy drop friction loss can be taken as K is equal to 1 minus 0.1, that is 0.9. So now in case of enthalpy drop exists, the velocity of the nozzle can be taken as C is equal to 44.7 into K square root of K into H1 minus H2. Therefore, if you substitute that, we used to get finally the velocity as 559.9 meter per second. Okay. So now the percentage of change in velocity between the percentage of reduction in the velocity is, the ratio is 585.9 minus 559.9 divided by 585.9. Okay. The value is obtained as 0.52. If you multiply with the 100, then we used to get the percentage as 5.12%. So that is the percentage of reduction in velocity that occurs due to the friction. Okay. Thank you.